Okay, so hello everybody. Um, I will be presenting about the tools and the catalogs and data of Spearhead, more of the technical aspects of the things, about the server and how we set up for the users to be able to view the results. Bear with me, I don't want to overwhelm you. And after I'm done with the presentation, Jan will have a more relaxed version of this, and he will go through our hub, etc., for you to see how it works, stuff like that. So let's begin. I will start with the Spearhead server. So in its current form, we have some resources in AWS, which are provided by the National Data Center, which is called GRNet. And we have, as of now, five EC2 instances, which are essentially virtual machines. Each one has its purpose. So we have one for the website, which runs WordPress, one for the Jupyter Hub, which we will see in a minute. We have one virtual machine for our communication, which runs Mattermost, and we have one for sharing files for in between the team members, the consortium. So it runs Nextcloud, and it also has the functionality via the Collabora VM to also edit and share files like Office files, like Word or Excel and stuff like that. So what we're interested in here is the web server with WordPress and the Jupyter Hub server, mainly the Jupyter Hub. So this is where the tools are hosted. So for you who don't know, for the ones who don't know, what is Jupyter Hub? It is essentially an open source platform for providing Jupyter notebooks to multiple users. It is accessed via standard web browser, and there is no need for a local installation of the tools or the notebooks or Python or whatever. And it supports collaborative, reproducible, and interactive workflows. So why we choose that? Because it's a centralized environment for data analysis and code development, and it is consistent. It provides consistent setup across the users. It is also secure, scalable if we need more resources and stuff, and customizable. So this is how it is set up. So we see here an example with the hub running behind an HTTP proxy. It is configured by some files. For example, here is a config.py. It uses various authenticators. For our case, we use GitHub. As Rami said in his presentation of Soler, the only thing that a user needs to have prior to logging into our server is to have a GitHub account. So by using their credentials of from GitHub, they can log in to our servers too. And here we have also custom spawners. Spawner is a helper function that is triggered just before the user logs in. So we can have some custom functionality here, and we also have some database and some administration. About specifically our Jupyter Hub instance, we use what is called the Litlist Jupyter Hub, which is a lightweight distribution of Jupyter Hub, and is ideal for small teams or single servers, since we don't expect to have like 1,000 users simultaneously logged in our servers. Then this is enough for our case, TLJH. It is simple setup, and the maintenance is also simple, and It is deployed on a dedicated server, in our case a virtual server, with, as we said, role-based access controls, since we can have different roles like administration and simple user. What are the benefits for the project? It promotes open science and data sharing. It is easy to connect with GitHub, and not just the login for the users, but also we can clone our Spearhead repositories, as Jan will show in some minutes, to its user root directory, so they can play around without needing to have prior knowledge about GitHub or any of that. And that's why it is easy for the users to run our tools. So that was about the server. Let's go talk some about the Spearhead data. So here is a diagram which shows the data flow of Spearhead data, the flow of Spearhead data. I think this is what Thanasis will show tomorrow, but I will have a quick recap, we'll have a quick look here now. So each PI has some data that wants to distribute to us, to the Spearhead server and to third-party agencies. First, the PI has to generate the data and store them to their servers, their respective servers. Then we need to somehow fetch this data. Probably they have an FTP server or web server. We create scripts to download them to our databases and servers. Then we have automated processes to archive these data through Zenodo. Then this is an ambiguous step, because we don't really know if we are going to, if the data are going to be shared through the Spearhead servers or the PI servers themselves to the third-party agencies and organizations like ESA or NASA. I think this is something you will talk about with Thanasis tomorrow. And then the last step is that we share the data with the users in tabular forms, so they can download them. So we are interested in this circled part here for now. So about how we will store, how we plan to store the data in our servers, we want to first fetch from the PI server and then store in what is called an object storage. AWS provides the S3 object storage, which is essentially a repository to store files in various formats. It doesn't matter if they are ASCII or binary files or whatever, and then we can access them through our VMs. For the archiving, we plan to utilize the Zenodo API. You can find more information through this link. Zenodo provides a nice way to test the API through the sandbox environment, which is more like a clone of Zenodo, but it is not public. DOIs there are for nothing. They just provide it for tests. And then, after we're done with that, we link to the official repository to archive and get proper DOIs for the data. And then for the sharing part, the plan is to have a view portal through the Spearhead website in the catalogs and data section, and the user will be able to download files directly from our website. Okay. Going to the catalogs now. It is kind of a similar approach. We have various catalogs, as Thanasis showed yesterday in his presentation. We have constructed catalogs with multiple detectors, multiple instruments, and various particles per energy. And we also have some external sources like HT or EPT. This is the, let's say, the data layer. Then we have the orange layer would be something like the view layer, where the user can view in tabular form the data we have. We can have linked events, and there is also the ability to for interactive selection. So, sorry, so the user can filter out and come up with the results they want, and also for other events, they can show plots and select specific events. And in the, let's say, the outputs layer, the blue one, the user can download CSVs or files or PNGs with plots. So how are we are planning to organize this? We have this schema in mind, and of course this is what we have come up with, and we're presenting that. So maybe you have some ideas that can help us. The main thing here is that we're trying to be to break it down as much as possible, because then we can have all the options we want. So the main thing here is the event group. So we have this event group table, which gets an ID. Everything gets an ID, and it has some sort of information associated with the event. Which sort of information table has everything about the flares, the CMEs, and the radio information. Obviously, these are all the information about them. I didn't write it down for demonstration purposes, because it would be huge. Then an event group, for example, consists of multiple events. So an event can have some particle information, and we can also see an event through multiple instruments, and every particle information event in the table is associated with a specific energy. So this is as broken down as we can get. We can have information about the background start, the background end, and the mean for the specific particle, for example, protons in specific energy and from a specific instrument, recorded by a specific instrument. We can have onsets. We have, for example, here a manual onset or an onset automatically detected by 3 sigma algorithm. And then the peak time, the peak flux. We can calculate some other measures like fluence, when the fluence start, when they begin to calculate the fluence, and when we end to calculate the fluence, and then some information about the spacecraft. For example, the radial distance, the longitude and latitude, and some other comments. So by having that, and of course I say again, every comment you have on that is very, very much welcome. By breaking it down, so what would the user need to do to view and download? So first, navigate to Catalogs and Data in Spearhead website. Then in the catalog section, there will be tabular information again with event groups. The user can select specific events, see specific energies, for example, see only specific particle species, for example, protons or electrons, and also the associated solar information. And after all the filters are applied, then the user can choose to plot data associated with their selection, or download in ASCII format, for example CSV or something like that, or of course both. And I think, yeah, that's all I had to present for you. I hope it wasn't too technical.
Okay, thanks a lot, George.
Thank you.
I liked it, but maybe do we have?
So do we have any comments on how the data and catalogs are supposed to be, or now it's the planning phase basically, because data and catalogs are being accumulated in the project, so it's a good time to get some feedback.
Okay, well, I've made this point before. There are some of those who don't know about Jupyter Notebooks and Python, all this nonsense stuff. Who are out there who'd like to use the catalog, and I think if you're going to say, so you're saying it's always easy, it's all this stuff, but you don't know what you're doing. So I broke the serpentine one. So I think if you're going to do that route, you need to very carefully. I know it's going to be tedious because you know all the stuff, but those users who don't understand what's going on, it saves you effort as well, because others will come to you and say, how do we use this? So it's, if you can do some documentation on how to use the catalogs, how to get into the catalogs, simple stuff. How do you change the dates? I broke that in serpentine. So I think it's important to do that. Or you make, if you can, I say it's in the web interface like you have the Solomach. Maybe there are some really important tools that can do that. But certainly I think you need to recognize that not everyone is up to speed on Jupyter Notebooks and Python and all this stuff.
I think for the catalogs, George, this is going to be straightforward, right? So the user will have an interface to play around, right?
Yes, the plan is to integrate this functionality in the website, so not through the hub, the Jupyter hub. So no notebooks involved, just forms and tabular data and plain old plots, I guess.
That's good, because I saw this in another earlier presentation that you need to use MATLAB or Python to access the catalogs. One of the other presentations, I was a bit concerned about that. Okay, good, this is good. You just, yeah.
I think there was the idea that we will also provide code to access the catalogs via MATLAB or Python.
Yeah, that's great.
If you want to do it, but you can also just use the website and click through it.
Yeah,
so
sure, just ignorant like the rest of some of us, yeah. Okay, good.
So if I understand correctly, you can do the query by events, no?
Yes, that's the plan. Yeah.
But also like on a time basis, like if I want the data from this to that and all the data available in that period, would it be possible?
Yes, the information also have the tables also have temporal information. So
no, I mean just. I mean, if you have a catalog, it's okay. You select an event and you have all the information, solar and particle, okay. But if I just want data in a particular period,
so you're talking about data, not the actual catalog
yes,
events.
Well, the idea is that it is kind of pre-calculated data for these events.
Mm-hmm.
So you can see the plots you will see are pre-downloaded for the specific periods of the events.
I didn't understand you, to tell you the truth.
I mean, if I, for instance, I'm a user and I'm interested in a period, I don't know, the year 2012, for instance, will I be able to download all the data that to the data products of Spearhead in that period?
You will be able, I guess, to download all the events we have for this specific period.
Okay.
Okay, but if you want to go to the data for this specific period, I mean, I just want to take 1 year of the data that are stored somewhere in the central server. Would I have a query to do this?
Yes, but this is not in the catalog section, it's in the data section.
No, not in the catalog section.
No,
yes.
general, okay.
It's in the data section, yeah, I understand. Yes?
Yes.
Yes.
Okay, thank you.
Okay,
I have a question for you, George. Are we
Oh.
going to have like a plotting tool for the catalogs? Like a web-based plotting tool?
Yes. But it's
You are
not.
committed to many
it's
people,
not.
not
No.
me.
It's not. It's not like too interactive though. It's a mix of pre-downloaded data and the dynamic part of it is the filters the user would apply for the plots. So the plots are not pre-generated, but the data would be pre-downloaded. That's the plan for now, at least.
Okay, because that would be more fast either way.
Yes,
right?
yes. We need to be, in between fast and what users want. So, yeah.
Okay. Any other?
Yeah,
Yes.
no, last thing. Maybe we'll discuss this tomorrow. But for instance, if going back to my previous question, if I have a period of time, will I also be able to say how many events are in that period just by, I don't know, as an interface?
Yes, so you should
Okay.
have a query and say, I want to see all the events, I don't know, in 2012, how many events I have in
Exactly,
this catalog.
yeah.
So you can take that. And there are going to be also identifiers. So
Okay.
that means that, for example, we have the Soho ERNE/F in Protons
Okay.
100 MeV, but we also have the
for
Soho
instance,
F
in this
electrons.
energy, I have 3 events. In this
Yes,
other energy,
and it could be different species. So larger than 100
Perfect.
MeV protons, electrons, or whatever happen in the same time range.
Okay, great.
Yes.
Listening to some of the questions, did you consider having a tutorial, like, maybe 6, 7, 8 months from now or something, where you get the interested users together and you show them how they can use it? Because I think some of the things that Ian, using your words, broke in the past, maybe he would not break them if there was a kind of one-day tutorial where there was a walkthrough on it. I mean, it can be online, right?
So that's a very good idea. We were just using internal users like Jan, Manon, myself, Nasrin, things like that. But maybe we can just do it either online or during some conference, like, I don't know, maybe European Speaker Week. Oh my God.
I think video tutorials.
Everybody does it today at YouTube.
I think video tutorials are great. I would also, though, have like a just online couple of hours type thing for those people that, would like to have some more interactive feedback.
Join us.
We have to make use of our YouTube channel, right?
Sorry, George?
We have to make use of our YouTube channel.
Right.
Yes.
Of course. That's a perfect place to put the video tutorial.
Yeah.
They're all in the room, right?
So Alexis has a comment for you, George.
To George, no, to everyone.
Oh.
George is included. So as part of the Solar Orbiter Modeling and Data Analysis Working Group, there's a Python team that Clementina Sasso put in place. And they're meeting regularly. And next year we want to relaunch the MADOG meetings more regularly. And so that could be something to do within the Solar Orbiter community, at least, to get some tutorials like we used to do many years ago on different tools and things.
I'm in that meeting already, so I'm aware. But it's still building up momentum, so it's rather, I think usually we are like 10 people there, so yeah, I think if you really want to do some tutorial session, it makes sense to either actively advertise it, record it, or connect it to some other event. I mean, maybe you can even go to some of the normal Solar Orbiter working group meetings.
I had a probably quite technical question. The databases, how are they stored and how are they accessed? Like what kind of API? Are you using this Happy API
What
interface?
API?
I'm talking about the data. I mean,
For the
I
data.
guess the catalogs could reference that API in order to grab it.
Well, for the data, since we are receiving files, then it is stored in the S3, and they're directly accessed by the VM. So the user will have the ability to download them via the website. We haven't thought about creating an API for automated downloads. If that's what you mean, we need to discuss that. But the catalogs, we're using standard SQL database, like MySQL or Postgres, to store data and access them. Yeah, that's so. But no. If you're asking about the public API, then we haven't thought about that.
So the question always is, of course, you can set up an Harpy server, but the question if it's worthwhile or because we don't have that many data products. So I would usually rather like to include it into something like CDA Web, which is already supported by Harpy, instead of setting up another server which you have to maintain and people need to connect to.
Okay, but you talked about files, George, and if you have a situation where you have a whole load of event catalogs, then they're often referencing the same data but with slightly different start and end times. But if it's a file-based system, do you then unpack all the files and then repackage them and deliver them? I mean, this is where a database system has strengths, right? Normally you would just set the start end time, pull out that data, and then throw that to the user in whichever form they wanted.
Yeah, depending on what data are we displaying here, in the data section, we are exposing files, but that's why I told that it would be pre-downloaded data. Depending on what data are plotting here, we are going to have them per event in databases. So they are easy to fetch and not recalculated.
Okay, that's interesting. I mean, for me, it just seems interesting, like that you would have the catalogs with all the events, and then you're going to have files per event per catalog, which then means you'll probably have a whole load of overlapping files because slightly different start and end times. It'll make your system quick in terms of the response, but it's going to be very inefficient in terms of the data storage. Maybe you don't care because the data is still not big.
Yeah, that's exactly that. I mean, users in websites, they are very impatient. So we are trying to be more. We'll easily sacrifice storage for quick access.
Everyone is probably wondering why the hell I'm asking about this. And the reason is that if you had like a happy type interface to a database, and then there was a question before about the plotting tools and the static or interactive. If you had that, you could, for example, take the KNMI space with a timeline viewer or something similar and just repurpose it for your needs without needing to do anything. So that could bring you a lot of benefits. I mean, that timeline viewer is one of the most looked at things when space weather events happen because it's so nice in terms of the way you look at data. And I know from Elko Dornbos that you can just grab that code, right? You don't even need to request it or anything. It's just publicly available. So if you have a happy interface, you can basically replace all the data in any of the panes with your data, and then you get it for free. And he's maintaining it, so great. Just a thought.
Yeah, that's a good suggestion actually. But George, did you understand? Did you make notes?
Yeah, I'll have to look through this happy interface because I don't really know about that. So.
Okay. But the whole point is that what we're trying to do, and this feedback is useful, is to try to do it as easily accessible to anyone and as easily reproducible by anyone.
So you can do everything nicely and perfect, but we have to focus on some things that.
Yes.
So the question is a bit also, what's the most important for the users?
But it relates to Monica's question, right? Let's say I want a slightly different start time for an event, so I just want to grab these data. Then suddenly the quickness of your system is lost. Someone's going to have to download a whole load of data files, unpackage them, and then replot them, and that would be a shame somehow, right?
Yes.
Exactly. So this is why I said that any suggestion or the questions you would ask, the users would ask, would help us optimize the system accordingly.
I did my job.
Yes.
Thanks a lot.
Your job.
Yeah, thank you, Piers.
It's a pleasure, George.
Do any other comments or maybe questions for the data or the catalogs or the distribution? Yeah. Wait.
One criticism I hear of these EU project catalogues is that they stop and they're not maintained and so on. So have you given any thought to what's going to happen to this catalogue at the end of the project?
Okay, so what we have now in our disposal is we have an AWS server from the, I don't know what Greek ministry is, but whatever. So this is granted to us for 5 years in total. We will be storing all the catalogs as simple CSV files with documentation in Zenodo. So it's going to be there, traceable, and anyone can use them. Also, data will be there, so they're going to be also citable. So if somebody is using the data, knows where to find them. Now, other than that, we can't really make a big promise in the National Observatory of Athens. The good news is that they are now building a computer center in our premises. So we are trying to get some space there because Spearhead is not that big. We don't have a huge amount of data or catalog. So if that's the case, then we will get a virtual server there. But for the first 5 years, we are on the safe side. That's
Okay.
Good. Yeah, of course. I just pull applications in the system. Yeah.
And then there are other data centers in Europe. So the plasma physics data center in France can also store it.
Yes.
It's been around for 30 years, supported by CNES.
It can be integrated to other catalogs, can be integrated to other databases. I don't know, to other forms, like SEP server or. Yeah.
Now you touched. The SEP server, for example, what happened to it? Is it all translated to somewhere else? Is it all ported elsewhere?
The University of Turku operates.
Right.
I think that nobody is using that.
I sometimes use it. Right? I mean, like
constantly.
Well, okay, wow, that's a that's a big statement. But I mean,
have a bias.
somehow the point I would make related to this is that it's then not accessible via the latest technology and these kind of things. So if we want to make a prediction for the future on what's going to happen with these catalogs, unless you do something like Alexi was saying, then probably you'll have a kind of outdated access in a few years' time because that's the way of things. So yeah, I agree with the criticism. It's a problem.
Yeah, that's true.
So no comment I get from my comments, the colleagues in the States, so these EU projects are really nice, but they just end and nothing happens after that. And okay, what did we learn in some ways?